Hey guys, this is the reteaching video for week 7, unit 3, lessons 4 and 5 cool down. For question 1, it says the scatter plot shows the maximum noise level when different numbers of people are in a stadium. The linear model is given by the equation y equals 1.5x plus 22.7, where y represents the maximum noise level and x represents the number of people in thousands in the stadium. What is the slope of the linear model? So here we can find the slope just by looking at the equation. Remember, when an equation is in slope-intercept form, it's y equals mx plus b, and m is the slope. So if we look at the equation, the m here, the number being multiplied by x, is 1.5, and so I can tell that the slope is just 1.5. This 22.7, that's your y-intercept. For question 2, it says, what does the slope represent in terms of the maximum noise level and the number of people in the stadium? So remember that our slope always means the rate of change, or in other words, the change in y over the change in x. So if I look at my x and y labels, my y label is maximum noise level, and my x label is number of people in thousands. So if it's the change in y over the change in x, it would be the change in the maximum noise level per number of people in thousands. So the best sentence that kind of describes that would be the first one. How much the noise level increases per 1,000 people. And again, I know it's increasing because this line, the slope is positive, so it's going up. For number 3, it says, which of these scatter plots shows data that would best be modeled with a linear function? So linear means line. So which one of these scatter plots would best be represented by a line? So these dots you can see are kind of scattered all over the place. I don't even know where I would put a line to make that best fit. The second one, the dots seem to follow a curve pattern, not a linear pattern, and so that one doesn't work. But the third one, these dots look like they could be represented by a line. So it would be that one. Okay, and then number 4, it says, which of the lines is most likely the line of best fit for the data provided? So here they're giving you that information as an equation. So my suggestion is that we look at the y-intercept. That's probably going to be the easiest way to pick out which one would be the most appropriate. Because if I were to draw a line of best fit, it would look something, I don't know, something like this. And when I look at my y-intercepts, the first one is 225. That would be like way up here. So that definitely would not work. The second one says negative 34.05. So that negative would be like down here. So I can see my line of best fit definitely would not go way down here. And then the next one would be negative 0.19, which would be just below 0. And that one actually looks like it would work. And then the last one was negative 21, so that would be way down here again. That would not work. So for your last question, what's the weirdest thing you ever ate? Go ahead and fill that in, and then don't forget to click yes that you completed the cool down.